Now we're going to be looking at complementary results. Now complementary results is results that are opposite of each other. For example here, complementary of probability of A will be 1 minus the probability of A, because 1 is the total probability. 1 is the entire probability, so if I subtract probability of A from 1, the remaining is what I'll get. So say for example, if P is the probability of surviving, okay, of living, then 1 minus P will be the probability of dying. So see how dying and surviving are complementary events because they're opposite of each other? So to get one or the other, we subtract 1 from that particular probability. So do you get the idea? That's what we're going to be using for the next few questions. So let's try the questions. Starting from 24, each question in a multiple choice test has 4 listed answers, of which only 1 is correct. A student guesses at random the answers to the 3 questions. So there's 3 questions he's going to be answering, and he guesses them. In part A, we want to find the probability that none of them is correct. Now 1 out of 4 is the probability that he'll get it correct. So the remaining probability, which is 1 minus 1 over 4, which is 3 out of 4, is what is the probability that he will not get it correct. It's wrong. So if he wants all 3 to be wrong, it's going to be 3 out of 4 times 3 out of 4 times 3 out of 4, which is simply 27 over 64. So you get the idea? So you're getting correct and not correct, they're complementary events. Okay? Now B, find the probability that at least 1 is correct. So we could have 1 correct, 2 correct, or 3 correct, but we can't have none correct. So we can't have them all being incorrect. Because it says at least, we must really identify what at least means. 1 correct, 2 correct, or 3 correct, but no, none correct. And we've actually found that probability here. We found that having none of them correct is 27 over 64. So having anything apart from that, it would be 1 minus that, because that is complementary of this. So we simply subtract that from the total probability, and that will give us the probability of having at least 1 correct. Okay, because the only event that we won't include here is when it's all 3 are not correct. So I've just subtracted it from 1, and the remaining is the answer to this question. So whenever it says at least, it's a good idea to think of subtracting something from 1. That's usually the shortcut of getting the answer. The probability of a product is defective is 0.01. So it could be defective or it could not be defective. And 2 of them has been selected. So part A, find the probability that both are defective. So if both are defective, this is the probability of having one of them having a product to be defective. So if it's both defective, we simply multiply them together because it's this and this. So it's simply going to be this. And then B, find the probability that 1 is defective, which means we want 1 to be defective and the other to not be defective. Having 1 defective and not defective are complementary events. So having not defective would be 1 minus 0.01. This is the complementary of that one. So that's what we do. Having defective and normal, or normal and defective. So again, consider the 2 events. Make sure you consider both. And then it will be 0.01 times 1 minus 0.01, which is 0.99. This is 0.99. Or 0.99, then 0.01. And then you add them because it's or, so you should get something like that. Use your calculator if you need to. Okay, and that's it guys. So the key thing is to find what a not defective product would have a probability of. Just subtract it from 1. Now C, find the probability that at least 1 is not defective. Okay, again we've got at least 1 is not defective. So like one of them could be not defective, the second, but 2 can be not, both of them could be not defective, but I don't want both to be defective. Okay, I don't want both to be defective. And I found the probability of both being defective in part A, haven't we? So we simply need to, well, that's what we want, which is at least one of them is normal, which is 1 minus both defective. That's what I said, isn't it? So we found this in part A, so we simply subtract it. This was the answer in part A, isn't it? So subtract it from 1, which is the total probability, and that's what you should have. Okay, so that's the probability having at least 1 normal or defective product.